Okay, operations on radicals. So radical stuff is the same as collecting like terms. So if I do 3x plus 2x, that's a 5x. Okay, same thing with radicals. So this has a root 7 in it, and this has a root 7 in it. So I can put those together. So if I have 6 of them plus 2 more of them, how many of them do I have? I have 8 of them altogether. Those have root 3's, those have root 3's. So if I have 2 root 3's and I take away a root 3, then I have just 1 root 3 left. Okay, so same thing here. I'm going to look for similar terms. So there's some root 5's and more root 5's to go together. And I see some root 7's and more root 7's, so they can be combined together. Okay, so we are going to say how many root 5's do I have altogether? 4 and 3. So I have 7 of them. And how many root 7's? I had 10, and then I took away 2. Okay, and then there's a plus 4, and it cannot be put in with anything because it doesn't have anything similar to it. So you have to make sure it's there. Okay, we have multiplying radicals. So root 11, root 3 makes root 33. Now, in this example, I have coefficient stuff and I have radical stuff. Okay, keep them separated. So what is the coefficient? There's a 2 times a 4. So the coefficient is 8. Root, and then the root times the root is root 18. Same with number 3. There's a coefficient 5. So it just has to be separated from the root. And then you can do a 7 times 8. Okay, on this last example, coefficient makes 6. Root, and then a 10 times a 10 is root 100. And you're not going to leave it like that. You can do stuff here. What is the square root of 100? Square root of 100 is 10. Okay, now there's no radical, right? Square root of 100 is a whole number 10. Then I can put those two together. Okay, so do you see how I'm always treating them differently? Coefficient number stuff, radical number stuff. Okay, I need you to give me all your perfect square numbers. You know what I mean? So like 6, I want a 36 radical there, right? Give me all your numbers with no calculator. You got them, right? Okay, so when you do breaking down radicals, you're going to need to think about those numbers. I'm going to call them perfect squarable numbers. Okay, 32. What can you divide 32 by? And when I say it, I'm looking for the largest divider. What is the largest number 32 can divide by in that set? 16. 16 times 2 is 32, right? Is that good? Did some of you try to pick 4 times 8? Okay, that's not the largest because it's also divisible by 16. Okay, so do you notice how I didn't change anything? Root 16 times root 2 is still root 32, right? That's still the same number. Then, what is root 16? 4, and then 4 root 2. Okay? My class, we did this last year, grade 10, this exact thing. So it's not fresh, right? You forget. Maybe a little bit. Okay. Can you pick a number up here? 300 is divisible by which? 100. 100 times 3 is 300, so therefore root 100 times root 3 is root 300. Then, what is the square root of 100? 10 root 3. Okay, so this is called an entire radical, and this is called a mixed radical. Okay, something you did exactly in grade 10. Okay, 20. What are you going to do with 20? What times what? Which perfect square is 20 divisible by? 4? Are you picking 4 times? 4 times 5 is 20. Okay, now 6 is in the front. It has to come along for the ride. I'm going to take the square root of 4 and change it to a whole number 2. Then I'm going to bring everything down. There's a whole number 6, and there's a radical 5. Okay, treating it like the whole number stuff, the radical stuff. So now I can do 12 root 5. Okay, I need you to divide 75 by one of those perfect squares. Which square number is 75 divisible by? 25 times 3, right? Don't forget, the 2 in the front is there. Okay, show me what the square root of 25 is as a whole number. Okay, there's 2 examples on the bottom. We'll just do one of them. Okay, give me 20. 4 times 5. We just kind of did this one. 20 is 4 times 5 in the radicals. Get rid of the radical here. So now that's just a 2. So did you get 6? 6 root 5? Okay, 48. What's your divisor there? What are you picking to divide by? 16, okay? Yes, it's divisible by 4, but there's more to it. So 16 times 3 is 48. Sixteen times 3 is how I got the root 48. So did you end up with a 20 in the front? 20 root 3? Okay, 45. What are you dividing 45 by? Do you have a number that it's divisible by? 9 times 5. Good. Subtract. Don't forget your subtract sign. And 12. What kind of number does 12 divide by on that scale? 4. Okay. Are you done? Do you think you're done this now? Is there more to go? Root 5s and more root 5s can all be placed together. So if you had 6 of them and you took away 18, you are at and there's some root 3s and there's some more root 3s. So they can go together. Okay, I just want to pay attention here. I get this often. 48, people put 4 times 12. Okay, it does break down, but look at 12 also breaks down. So if you had picked that, it wouldn't have broken down fully, because if you had left a root 12, that still can go down. Okay, last set of stuff here. Okay, multiplying. Okay, so we know how to multiply polynomials like that. Outside times first, outside times last. Okay, so here we go. Whole number what? Radical what? 8 root 15. Do you see it? There's an 8, 15. Okay, now I'm on to this set. What's in front? What's the radical? Minus 4 root 21. Okay, number 2, without me. Go. You can do it. That and that. Okay, so I got an 8 root 70 on that. And then here I got a 10 root 49. Okay, did you stop there? Or did anybody keep going? Because there's something to work out yet. Can you spot what I could do? Is there anything that I can do to this? I can square root 49. So that would be a 7. Okay, these are not similar terms. Do you see that? This is a root 70 and this is a whole number 70. They cannot go together. They don't mix. Okay, this process here is the same as how you distribute a multiplication. See how I have to multiply this and this? Same thing. I have to do a division, a division, a division. I have to take turns doing all of them. Okay, so here we go. 11 divided by 2, that's a decimal or a fraction, so you can do whatever you want. Leave it, or what would it be, 5.5? Root, so look at your roots. You have a 33 divided by 3, so root 11. In the middle, 8 divided by 2 is 4 root 12 divided by 3. And then the last one, 16 divided by 2, so that's a minus 8 root. Okay, there's more to go here. I can break down some stuff. I can see a root 4. I can see a root 9 in here. And I can put stuff together. Okay, and then that's how as far as I go. Number 4. What do you think we should do with that kind of multiplication? 2 things, and then there's 2 things. Anybody have something for me to do? Bobby's saying you should do this and this and this. What's the name for this and this and this? I should FOIL this out. Okay, so first times first. 10 root 21. Outsides 4 with a radical 3, right? Insides, there's a 40 with a radical 7. Do you see the parts? 40 root 7. Last plus 16. And I think when I scan that over, I'm done because there's nothing to put together. This root, this root, this root, can't do anything with them. Okay, number 5. FOIL. Okay, on your own and then check to see if yours matches. Okay, there's all the 4 pieces. Now, look at this, minus 5 root 15 and a plus 5 root 15. What does that do together? That'd be 0, right? If you do that together. Then root 9 is really a 3, so that first is actually a 75. Root 49 is really 7. What did I do? Oh, how did I get that? What? 21. 21. Like that? Now I'm good? Thank you. I knew it was gone, so I wasn't paying attention. This is good, 75, 7. So that makes final answer 68. Okay, so this is a special thing. We're going to learn more of it. But this is kind of the same idea as doing a difference of squares, kind of, when you have a plus and a minus. And there's a word called conjugate. So what's kind of the definition of a conjugate? A conjugate is the same numbers in the places except for a plus and a minus between them. So guess what conjugates do? Conjugates will always have that happen to them. My foil can cheat and become a fle. Okay, last example you're going to tackle on your own, but I want to show you what does it mean to square something. It means repeat it twice. Squaring something means repeat it twice, and I'm sorry, there's no shortcutting. You're going to have to foil it. So an example of a mistake on this question is people square the first item and they square the last item and that's it. That's a mistake because you're squaring it as a unit. You're not squaring individual things. You're squaring the units. Okay, go ahead, finish this out on your own.